Alright, so today we're going to be doing the division rules. Okay, now listen, technically, when you do your little division rule, you say, okay, I got like bases, so when I'm dividing, I will do what with my exponents? Subtract. That's technically what you do. So let me show you how this would work. Y'all would think this probably, not write it down. I'm going to write it down. So on my A's, technically, I have 10 minus 2. It's always the top minus the bottom, always, okay? Then on my B's, I would have 9 minus 4, technically. So that would give me A to the B to the... And I know most of y'all could skip this, but I'm showing you. Okay. Furthermore, y'all wouldn't even have to do the rule here. Y'all could say, stay with me now, y'all could do your canceling like you do sometimes. You could say, I got 2 of these, and that'll leave 8 up there. Got 4 that I could cancel, and that'll leave 5 up there. Either way. Now, why then do we need to know the rule? Here's why. If you have a problem that has negative exponents in it, you can't cancel. If you got negative exponents, guys, you can't cancel. So that's why we got to know the rule also. All right? So look at the next one then. That's junk down there. I'm not even doing that. All right, so look at the next one then. Okay, start with the numbers. Numbers are numbers. Treat them as usual. 12 divided by 6. I'm going to put my line out here. All right, so because I'm guessing there's stuff on top and stuff on bottom. We'll see. All right, so we got x to the 7 minus 6. So x is to the first, technically. You don't have to show that. All right, y to the 8 minus 3, which is, all right, now what's on bottom? Really, nothing's on bottom. Because we took care of this, so technically, we could just say that. Okay? All right, so. Now this one's got a combo of stuff, notice. We got cubing everything here, and then we've got division going on. So we got 2 things. Y'all with me? Yeah? Okay. We're going to cube everything before we do the division. Now notice, everything gets the 3. Even the 2, even this 3. Because remember, technically, that's what they are right there. So 2 is going to be to the 3rd. A is going to be on top here. A is going to be to the, and B to the, thank you. All right, now we do the bottom. 3 is to the 3rd, and B to the, thank you. Okay, so we've taken care of distributing that cube on everybody. All right, now let's clean up our numbers. What's 2 to the 3rd equal? What's 3 to the 3rd? And if you didn't know that off the top of your head like she's doing, then type it in. So 8 over 27 is really what these are. Now, can that reduce or anything? No. So that's going to stay 8 over 27. We're done with that. All right. Now, look at your A's. We only have that A to the 9th. We don't have anything else. So it's staying A to the 9th because nothing's in common with it. But look at your B's. B to the 15 minus 6, which is B to the 9. Notice, every time I use the rule and I subtract, my answer ends in the top. When I use the rule to subtract, no matter, your answer is going in the top, never the bottom. Now, you might want to fix it after that. I'll tell you what I mean in a minute. But it lands in the top. So we're done. That's as much as we can do. Okay. Now, We did that. We've already done that one, so skip that. Now, we haven't done this, and it's not on your sheet, but put it down at the bottom, maybe. Stick this down at the bottom. First, this one. There's a reason. I noticed when I did this that we needed a little something before we did the next problem. All right, so if you have a negative exponent, that's not done. It's not simplified. The only time you can have a negative exponent and it's okay is scientific notation. And the only reason it's okay in scientific notation is because it tells you which way you just moved. So that's the only reason that's okay. Other than scientific notation, you can't leave it a negative exponent. I know you did on your homework yesterday that we checked because I hadn't gone over it yet, so I just didn't worry about it. But as from now on, we don't want to leave a negative exponent in our answer. So here's how you fix it. Pretend that you're looking at an x to negative 2. If I wanted to get rid of that negative, I would bump it down a level. In other words, technically, that's what you're looking at, right? Technically. If I wanted to make it a positive exponent, I would make it this. Here's what I did. I took and bumped down. When you change levels, doesn't matter if you go top to bottom or bottom to top, doesn't matter, exponent changes signs. Now, why did I leave a 1 there? Because once I moved that, you had to show a placeholder. If I didn't show a placeholder, it wouldn't look like it was in the bottom level. It would look like x squared, and that doesn't make sense. So if nothing is left up there, you show 1 placeholder when you bump it. If you've already got other stuff up there, then you're fine. All right? Here's another one. Let's look at it from the other viewpoint. Pretend that you're working a problem and you get to here and you're like, well, I can't leave this negative. Same idea. Change levels. Bump this up and it becomes positive. So it would become that. Anytime you change levels, exponent changes signs. Now, here's the other thing. If there's other stuff involved, you only move what is negative exponent. Make sure y'all see this. If I pretend that was the problem, pretend. The 2 wouldn't be moving. If that was the problem, that'd be the answer. You only move what has the negative exponent. 2 is to the first, technically. So it stays put. So be careful that you're moving only what needs it. All right? I needed to say that for us to do the next one. All right? So here you got some negatives. So here you can't cancel like we did a minute ago. You can't go, oh, there's 3 and there's 2. They're negatives, so we can't do it. So we're going to go through and we're going to use the rule. And then if we still have negatives, we'll bump and fix. Okay, let's start with the numbers. 4 over 16, 1/4. That'll reduce. So 1 over 4. All right, so done with that. Now let's look at the a's. Here's what we've got. If we use the rule, we've got a to the negative 3rd minus 2. I'm going to write that down. A to the negative 3rd minus 2. I'll leave it there for this moment so our eyes will have it. All right, do the b's. B to the 6 minus negative 2. Technically. Now, so let's clean it up and see what we got. 1 over 4 is good. All right, A is really going to be to the what? Negative 5th. B is going to be to the 8. Yeah, add the opposite, and it's 8. So here's what we got. Here's my only issue. Everything's good here except my A's. The A's have the negative exponent. Therefore, the A is the only thing that needs to pick up and move. So we're going to bump the A down. So we're going to have everything stays put, but the A bumps down with that 4, and when it does, it becomes positive. And that would be good. Make sure you're okay.
No, you confuse me.
Where?
Why do you keep trying to change that 6 minus 2? 6 ain't negative.
No, 6 in there. It's 6, add the opposite.
Oh.
That's how, yeah. All right. So otherwise, we're good there. Okay. All right. So let's look at the next one. There's one more, I think. All right. So here's the bottom one. Okay. So here we got multiply, we got divide, we got zero, we got a negative, we got everything. So let's start out by doing this. Let's do the x's, subtract. So technically that's x to the 4 minus negative 2. 4 minus negative 2. So be careful. And then y to the 0 is really equal to 1. So technically that's times 1. No y, just 1. Alright? So really all we've got is x to the 6 times 1, or just that. So we're just going to get some practice on that today, and probably tomorrow I'll do mixed practice with all the rules. Are we good? Thank you.